one and all. Today we have an eminent speaker, Dr. Hari sir, who is professor in Department of Information Science and Technology, as well as our Deputy Registrar of JSA Science and Technology University. Here we have a very brief, very brief, sir, very brief.
No, you just go to Google and type BS Harish JSS STU.
Yes.
Okay, you'll get all my.
Yeah, that is what I have taken.
Okay.
No, I want to highlight a couple of things, sir. Apart from all these, publications, etc. Sir was a visiting researcher at Department of Informatics, Bioengineering, Robotics in University of Genova, Italy. Sir has handled several projects. BGST project on machine learning in automated text, Kannada text, categorization. AICT RPS project on classification of text documents. And very interestingly, sir has been awarded or been placed first place in Graham segmentation task in Japan. First place in segmentation and second place in recognition in Sclera segmentation benchmark computation, ICB, Sweden. This is what I wanted to highlight. Like many of the speakers have been told about the computation regarding the data set. In such case, in such scenario, sir has bagged 3 different awards. Taking up the data set and proposing their model upon it, competing over there and getting award at the world level. So this is a very good introduction, sir.
Thank you. Thank you very much. So thank you, and I also thank the organizers, Professor Bharti ma'am and Professor Harshita ma'am for giving this opportunity to share some of the experience of what actually we did at our research lab. So this is not basically the kind of presentation that I am going to give. It's more or less the experience that I am going to share, that what we faced during solving this particular problem. Right, so I will come to that, what is basically Sclera and all at the later stages. So I have time till 12 o'clock.
Yes.
Okay, so 120 minutes. So probably it will be a very, sometimes you feel exhaustive sitting for more than 90 minutes. So whenever you want to stop, you please let me know. So we'll stop and we'll take up some case studies or any queries or any questions. Okay. So and then we'll continue with our the regular discussion. And the biometric or whatever we discuss from, because I've seen some of the very interesting sessions that were organized by the organizers, but more or less all these topics are not the topics which can be covered within 2 hours or which can be covered even in 2 months. Right, so even in 2 months or even in 2 years for the matter. So it's all the vast discipline which is the order of the day, that is the biometric. So probably the very recent kind of words that we are seeing, especially in the newspapers or in the TV news, right? So I'm not talking about any international news. I'm talking even the Indian news, right? So even the Indian news, or if you just take some of the best examples, it could be the state of Karnataka, or even it could be the place like a very small place like Mysore, right? So more or less, if you have an habit of reading the newspaper, I think there was a wonderful news yesterday, in the Times of India. So it was in page number 4. Suppose if you have not done, maybe you can just go through it, right? So e-paper. So 2021, right? So from 2021, right? So the 2021, during the entire year of 2021, so the cybercrime departments throughout the India, right? So throughout the India was used to get register of around 45 cases per day. 45 cases per day, right? So per day. And if you see the second quarterly of the 2022, So I was, I told the 45 cases per day in 2021. And if you see the second quarterly of 2022, and it was in the newspaper, right? So you just go to the e-paper, Times of India, and you will get the news, that statistics. And they'll say every day around 1,600 cases are reported in each and every place or the police station, especially in the cyber departments. Right, so why is that? Right, so why is that? Right, so that's the very interesting question that we are supposed to answer. We being an computer science engineers, or we being an the researchers who are working on the advanced topics like biometrics and all. So I think just 3 days back or 4 days back, once again there was a news, even in the local newspaper, there was one missed call. Right, so that came to one lady, but she is highly educated, probably you might have read. And within a span of the one missed call, so which was, the call was picked for almost 24 seconds. Right, so the call was picked for almost 24 seconds. You won't believe it, she lost 2.6 lakhs. Right, so she lost 2.6 lakh. But how? That's the big question mark. Right, so that's the big question mark. And the very interesting solution that we are supposed to find is something is happen which is very unusual, right? So something is happening at the back end, right? So which is unusual. So people used to use a word called dark web, right? So people call them it as an dark web. That is, somebody is sitting at the back end and they are trying to pull the data, right? So manipulate the data and do all these things. Right, so that is the actual problem that we are facing. It's all because of the two important reasons. Right, so one is obviously the digitization. Right, so one is obviously the digitization. Right, so the digitization, I mean to say, see, I don't think so that you are all really carrying your, the wallets now. Right, so the wallets which really carries your cash. I don't think so. Right, so probably it has reduced to the very minimum, especially people who are little educated, right? So people who are really little educated, right? So because everything is done through your different sets of UPIs, like Google Pay, it could be Phone Pay, or it could be Amazon Pay or Airtel Pay, whatever, right? So but is it safe? But we never ever give a thought, right? So the levels of security, right? So maybe you need to, the first to open your phone, you need to give the, security, right? So you need to give the authentication to your device, right? So the second one, if you want to access that app, again you need to give the authentication, right? So then it uses the user ID, right? So then it uses authentication ID. Then if you want to do some transaction, the transaction ID. See, you are doing at the different levels, but still this is a threat that we are facing. Right, so I think this is a really a challenging problem, especially not only the country like India, which is a developing country, is facing, but the entire world. Right, so but the entire world. But I try to show some of the statistics, right? So which really, which really gives the importance of I forget about these things, especially with this is a very interesting word nowadays. People are really looking into it, right? So that is the biometrics, right? So before that, I think I was, I'm just asking you because the topic says, the title of the FDP says, the research avenues in biometrics using low-cost devices. Right, so I think research avenues will leave it, right? So whatever we discuss, everything can be considered as an research avenues. Right, so even I think yesterday Professor Guru sir was talking something about AER and EER, even that is a research. Right, so even that is a research. Right, so whatever we think, and if we think from the perspective of unconventional, that will become a research. Right, so we'll forget that. Biometric will take at the later stage. And what is this low-cost devices? Right, so the organizers have coined a word called low-cost devices. Right, so what is these low-cost devices? Right, so is it, the low-cost, I don't think any of the speaker has discussed about this. No. Yes or no?
That one paper we had.
No,
Not specifically.
not
as
specifically
the-
with respect to the low cost devices, right? So it's not, the organizers doesn't mean to say that the expenses of devising the device to handle the biometric is cheaper. No, that is not their intention. That is not their objective. Because when I spoke to the organizers, at the very beginning when they, approached to give some, specific talk, right? So this is what they expressed, right? So I'll just try to clear from the perspective of the organizers that the low cost, it doesn't mean that the device, that whatever we are using are cheaper in its cost. Right, so after all, if you want to capture the fingerprint biometric, what is the simplest device, or what is the cost of the device? The simplest device. If you see the market, you will get it for 400 rupees. Right, so you will get it for 400 rupees. To the what level it is giving the authenticity, it doesn't depends. Right, so it doesn't depends upon the device that it's going to capture. Right, so it's something else. Right, so it's something else. You will capture the fingerprint. Then what exactly you are going to do? What's your name? Okay, Chandrasekhar. Right, so Chandrasekhar is going to capture. He is going to give the fingerprint. What exactly happens at the back end? Right, so to say that this is the fingerprint of Chandrasekhar. Right, so that is where actually we need to think of the low cost. Right, so low cost, it's not from the sense of
Device.
only the cost. Right, so only the cost. After all, to devise the entire device itself, I think we have a professor from electronics department also. Hardly you need a simplest and simplest breadboard. Right, so simplest and simplest breadboard and a capturing mechanism. We'll call it as the acquisition mechanism. Right, so and rest everything is done. Right, so on a simple piece of breadboard. Right, so then what exactly really is needed?
Time algorithm, which is
Very interesting answer. So she said something called algorithms,
very
time, right? So
Testing.
algorithms, time, and she's telling testing. Any other answers? Any other answers?
Efficiency.
Right, so efficiency, and then the accuracy, right? So these are all the words which really put together, and they have coined the the word called low cost. Low cost in the sense your device, right? So your device, obviously it should be cheaper, right? So obviously it should be cheaper, right? So then the next comes, right? So Chandrasekhar, if I take the fingerprint through this device, what is the level of efficiency that, as she said, that I am getting? That's the big question mark, right? So and she said something about the time. Right, so yesterday, I think when Professor Guru sir was, showcasing that attendance system, right, so you tell from your art, right, so we got, some kind of, irritation probably because it was taking too much of time, right, so when the other user, comes and again suddenly the system went down, right, so again he has to put up the system, right, so but what was the amount that it was taken? Right, so and where exactly you needed this, where exactly this deployment takes places, especially in the very crowded regions like airports. Right, so if you see airports, right, so if you see Newark airport or John F. Kennedy airport, right, so you cannot imagine the population. Right, so you cannot just imagine the population. Right, so can you just, can you tell the security check, right, so that you are, give your fingerprint 2 times, 3 times, 4 times, right, so people are really, you get frustrated for that, right, so she said time, within what time, right, so probably it depends upon the individual patient's time, right, so maybe his patient's level could be hardly around 4 to 5 seconds. What is your patient's level?
Depends on.
It depends.
On am I late to the flight or do I have time?
But what is your patience level? Right, so it depends, right? So it's as simple as you go to Google and type something, right? So what is the patience level that you have to wait the results that you are going to get for the query? Right, so probably a seconds, right? So maximum of 2 seconds or 3 seconds, right? So not more than that, right? So can you come out with, such a very interesting, algorithms, because already she used the word called algorithms, right? So such that it does everything within no time, right? So it does everything within no time, but she said something called the efficiency, right? So efficiency and the accuracy, right? So because we are trying to play with something, to identify that this is a Chandrasekhar, right? This is a Chandrasekhar, right? Right. So see, efficiency and accuracy both really matter said, right? So at that context, right? So within no time, right? So within no time, I have to tell that this is a Chandrasekhar, right? So that is actually you are supposed to give a thought, we being the researchers, right? So and no doubt, right? So if you see every day, I think especially the beginners, right? So the researchers in the beginners, and if I tell, for example, Chandrasekhar is a beginner in the field of biometrics, and if I say you just take this paper and you go through this paper, and you are supposed to work on face recognition. If this is the problem that he is supposed to work, he'll come with the answer after 1 week saying that, sir, it's already we are getting around 96% of the results, 97% of the results, 98, 99% of the results, and people are talking something about multimodal, fusion, hybridization methods, and people are talking something about deep learning. So everything is totally saturated, sir. There is no anything that is left out. But still you insist me to work on this topic?
Yes, sir.
Yes, definitely yes.
Even I got the same.
Right. So yes, obviously it should be, and that is how actually the researcher, will start his research work. Right. So you will feel that everything is saturated. Right. So everything is saturated. But if you just go back when Bharti madam was doing her, PhD, I mean she did her PhD on this biometrics. Right. So and when she was doing, right, so a small changes could be a wonderful breakthrough in the research. But now it's not so. Right, so now it's not so. Right, so even people are trying to fuse so many, traits. People are going with the face, with the fingerprint with the gate with the signature. They are trying so many combinations, but still 1,600 cases getting reported every day. Right, so why can't you use the biometric traits, that are already very well established and accepted, in the present market? No, we cannot. Right, so that is where the research avenues, that are available, and the low cost. Right, so think in these directions. And she was telling something about the results. Right, so she was talking something about the results. And we being the computer science engineers or computer science researchers, so we need to give a thought, how optimized, right, so how optimized, right, so the level of the ranking that we are going to give, the level of accuracy that we are going to get, right, so the level of the time, minimum time that it takes, right, so to say that this is what the result that I am going to get, right, so to say how optimized your algorithms are, to say how optimized your indexing is at the back end, right, so it should be so best optimized, right, so see, that is where actually you need to give a thought, right, so try to think of very simplest models such that the optimization is achieved to the best, because that is the present trend that is going on, especially in the field of these biometrics, right, so how optimized, right, so how optimized, right, so maybe attendance system, when you were showing, you could have shown something, the face that is covered, right, so probably the off face that is covered, but still it recognizes. Your expectation is yes, it has to recognize it, right, so your expectation is yes, it has supposed to, but is it doing? Then you cannot consider it is an optimized, right, so you try to devise a system which is of low cost from the perspective of the cost, right, so from the perspective of the cost, from the perspective of the efficiency of the algorithm that you are going to build, the efficiency of the ranking, right, so the ranking algorithm that you does, right, so and where exactly you are going to store it, right, so how fast the system is, because even that also matter, right, so there are so many things that you are supposed to consider, right, so each and every word, every parameter, right, so will become a breakthrough, right? So will become breakthrough, right? So 99.9% achieved in the face recognition. You forget it. Don't worry about the accuracy, but it is giving the result by taking 4 seconds. Can it be optimized, right? So and try to showcase that you have achieved within 2 seconds of 99.9%. Then definitely your model will be accepted and not the exact 99.9. But it is always a trade-off, right? So it is always a trade-off. So what is basically a trade-off, right? So depending upon certain circumstances, right? So once you give the priority for one set of parameters, obviously you will be having another set of parameters, right? So where the weightage will be gone down. For example, whenever you are going to give the financial or doing some kind of financial transactions using your trades, right? So you are not affordable to lose even a single rupee, right? So you are not really affordable to lose even a single rupee, right? So but let it take its time, but I want the best accuracy. But if you just take the example of an airport, no, I want to get pushed off from this airport. For example, Shah Rukh Khan, you take Shah Rukh Khan, how many times he has been hold in the airport? He is a very popular figure. But many times he has been holded in the many of the international airports. Why? Because of the name. Right, so because of the name. Right, so because of sometimes maybe the actual face, that whatever he has given, right, so at the port of exit and whatever the face that he is going to show at the port of entry in the other country doesn't matches. Right, so it doesn't matches. Right, so these are all the things that you need to really consider. Consider all these parameters, right? So can you make your device, right? So by considering all these parameters as in low cost, right? So as in low cost, right? So it was a wonderful example that he was giving the attendance system, right? So you just take that, suppose if it is really, worth deploying, he was telling, that could be deployed into the many classes, schools and all. It could really save, the much timer, because we see especially in our kind of context, we'll be handling around 60 to 65 students in a class, and each teacher calling everybody's name, 60's name. A name takes 30 seconds, right? So to call RK Bharati, right? So RK Bharati, then he has to look at, because proxy, right? Right, so proxy, right? So then yes, okay, 30 seconds. So you just calculate the time. Right, so minimum every class, right? So every class it will take 5 to 6 minutes to put the attendance. It's good that if they call their name, sometimes teacher will also call by the roll name, roll numbers, roll number 1, like the prisoners. Right, so like roll number 1, roll number 2, roll number 3. But once again you are supposed to lift your head and see whether he has actually come or not. Right, so you just take your laptop, right? So you do this. Right, so for the entire classroom, right, so obviously almost all the laptops comes with the cameras. You switch on the camera, let the algorithm running in your laptop, open the camera and you do like this, right, so that's it. All your faces should be captured instantaneously, right, so it should get matched with the database and it should automatically mark, right, so whether the student is present or not. Right, so this is what the expectation, right? So this is what the expectation, right? So from out of your, but it should be very cheaper, right? So it should be very cheaper, right? So because the cost, right? So really matters a lot. Cost in terms of all the aspects, right? So that is why actually they have given the name called low cost devices. And Sclera as a modality, coming to the actual topic that I am going to discuss. This is something which is very interesting, right? So anybody has worked here on Sclera? Okay, so this is Iris. Iris, anyone has worked on Iris? No. Okay, anybody has worked on biometric except Madam? She's working on biometric. You are working on what, right?
Signature.
Signature, right? So signature, right? So there are a lot of challenges. Signature, right? So I tell you what are the different challenges, right? So we'll just try to see some of the very interesting aspects, right? So with respect to the Sclera as a modality in biometrics. So this is very interesting statistics. You can really capture something, which is very interesting, right? So in these statistics, especially if you see, right? So especially if you see, in 2021 it was in the 9th place, and 2022 India has pushed to 2nd place, and last 10 years back India was in the place of 78 or 79. Right, so you can just go to Wikipedia. This is the source that I got from the Wikipedia. Right, so but see, there are around the smartphone users. Right, so this is about the smartphone users, and 606.57 million people are using smartphone. Right, so and the percentage of penetration of the smartphones, right, so is 43.5%. Right, so 43.5%. Right, so maybe you can just think. Right, so you can just think, right, so if you just compare to the other statistics, see Russia 71.1%, it's doing good, and if you see Japan, it is doing 75.2%, but my figures doesn't really mean there, my figures really mean here. You see the population here. Right, so you see the population here, and USA after all, 33 crores, that's it. Right, so USA, it's after all 33 crores, but the penetration of smartphone is 72.1. And but if you see the Indian statistics is something which is really very scary, right? So 1.4 billion, right? So 1.4 billion, and it is 43.5%, right? So something which is very alarming, right? So then, question is why? What does really affect us, right? So as the number of smartphone increases, right? So because the name itself tells it's something smart. Right, so the name itself tells that something smart. Right, so and the name itself tells don't carry wallet. Right, so because there was something which is very famous and interesting, WhatsApp message that has been circulated previously. This mobile phone has replaced so many things. Right, so including your alarm or including your watch, it's so many things. Right, so now, right, so obviously your wallets are also replaced by your phones. If your phone is lost, right, so then that is where actually you need to give a thought here, right? So that is what this number 43.5% is really and very alarming, right? So it's really and very alarming, right? So you should really give a thought, and there is a lot of scope that is available. That is for sure, right? So that is for sure. And another very interesting statistics is this. This is a very interesting statistics, right? So here, this is not reported by someone, the state government or the Indian government. This is reported by the United Nations, right? So this is reported by the United Nations, and it says mobile telephones more common than toilets in India, right? So more people in India, the world's second most crowded country, have access to a mobile telephone than to a toilet, right? So according to a set of recommendations released today by the United Nations University. This is still alarming. Right, so this is still alarming. Right, so you see everyone, right, so it has penetrated to the best extent, right, so highly appreciated. Right, so that is what the level of penetration that this technology has done. But at the cost of what? Right, so at the cost of what? At the cost of something else. Right, so at the cost of something else, right? So that what I was telling about, the reporting of 1,600 cyber cases every day, right? So why not we really, give something which is really the best out of best, because we are all sitting here to give some best security mechanism for this kind of digitization process, right? So some digitization process. Right, so these are the these two slides can be taken as a motivation, right? So to work on any biometric, right? So you can just use these two slides, and you can say that is why you are trying to work on biometrics, right? So the actual, the cryptography security mechanisms are even to the certain extent. Nowadays, people are talking something about the blockchain, right? So blockchain, but still the blockchain, right? So is really inadequate, right? So it's really inadequate, right? So to satisfy the level of security that is being, expected by the end user, right? So that is being expected by the end user, right? So these 2 slides are more than enough to showcase yourself, right? So that why we want to work on the area like biometrics, irrespective of any biometrics, right? So that is the secondary, and more or less each and every places nowadays it's all surveillance, right? So it's all surveillance, each and every place, right? So it's all surveillance, right? So that too the very sensitive airports, right? So that too with the very sensitive airports, right? So a good example that can be given is just go to the airport, right? So you carry some bag, you keep that bag with you, right? So you keep that bag with you, just you go to washroom 4 to 5 times, right? So continuously within the short span of time, 4 to 5 times within the short span of time. You keep your luggage, you go to washroom, come back. Again you go to washroom, come back. Again you go to washroom, come back. Right? So you see the consequences. The very next minute, the security personnel will be in front of you. Because that is an unusual event. Right? So because that is an unusual event. Right? So something which is very abnormal. Nobody will go to washroom 4 to 5 times within this small span of time, right? Right. So then who is tracking this? Right. So who is tracking this? It's all surveillance. Right. So it's all the surveillance, and it's practically impossible for any security personnel just simply sitting and tracking. Chandrasekhar has gone one first time, so he has gone second time, he has gone third time. No, it's impossible. Right. So you should have some mechanism. Right. So you should have some mechanism, right? So to say that this is an abnormal behavior, right? So even that abnormal behavior can be in so many ways, right? So that abnormal behavior could be in so many ways, right? So you have a trait called gate. I think HSN might have discussed that, right? So through the gate itself, right? So you can do so many wonders, especially with these surveillance videos, right? So that is what actually you can really think of. Right. So this is, I think, this more or less you might have seen by the different speakers who has given this. Right. So the various biometrics, and basically they are classified into biological analysis, right? So behavioral analysis and the morphological analysis. Right. So biological analysis, so that is DNA. Right. So DNA, so which is very unique. Right, so which is very unique. Even a single strip of hair is more than enough to say that he comes from this particular family. Right, so I think Aftab case, right, so very recently you might have seen, that was the breakthrough. Right, so DNA, right, so this is very interesting, and people are talking something about, people were talking something about the, blood bank, right, so the organ banks and all, it's all gone now. People are talking something about the gene banks, right? So people are talking something about the gene bank. So that is why I was telling it's an amazing area to work on, right? So gene bank, right? So can it be stored and can do replicate, right? So can do some kind of an replications, right? So that is where actually you can consider that as a biometric, a body odor, even that is a biometric. Right, so nobody imagined, right? So, but still but how to capture that is the other side of research, right? So, but that is basically can be considered as a biometric. Blood and the sequence in the bloods, that what exactly you are going to see in the sequence, right? So that is very unique, and physiological signals, right? So physiological signals. Right, so the reaction that you are going to give, right, so the reaction that you are going to give, right, so it varies from person to person, right, so suppose if I do like this, see, that is his reaction, that is basically a physiological actions, right, so what exactly happened, right, so something got triggered here, right, so something got triggered here, and it went here, right, so and it went to the brain, and then the brain tells that idiot is trying to hit you, right, so that is why he is trying to react, and if I do it second time, you won't react. Why is that? That's the physiological, kind of signals, right? So okay, that is unique, right? So that is unique, right? So if I do it the same thing for the second person, it will be simply sitting like this, right? So that varies, right? Right. So that varies, right? So physiological signals, right? So and if you see behavioral analysis, voice, gait, right? So gait, the walking style, right? So the walking style itself is different, right? So when you see the very old legacy of the gait recognition when it came during the 1970s, you won't believe it. The one of the best fundamental features that was extracted to discriminate between the male and the female, you know what? Can anybody tell?
Walking style.
Are what feature? Gait is a walking style. What is the simplest feature they considered to discriminate between a male and a female?
Movement of hands,
Distance between foot
distance
Heel
between
size.
Heel size.
the coordination between the legs and the hand.
Right, so usually whenever ladies walk, right, so the hand swings like this. Right, so the hands swings like this. Right, so it comes from left to right and left to right to left whenever the ladies walk. Right, so and whenever the male walks, right, so it usually goes from front to back. That was the first fundamental feature that they started during the 1970s. But you see the research now, right, so you see the research now, right, so it has gone into the best out of best extent, right, so it has gone into the best out of best extent. That is what actually Dr. HSN has presented, right, so the previous day, right, so it started with simple, hand movements, right, so and we have done so many things, right, so gait, right, so that is gait. And signature dynamics, I think she is working on, right, so you are working on signature, right, so that dynamics, tremendous scope, right, so still the signature, right, so plays a very, very critical role, right, so plays a very, very critical role. And people are not really worried about nowadays, yes, right, so online signature, offline signature, writer dependent, writer independent, there are so many things that are going on. But nowadays, if you take the actual fact, right, so these two words is playing a very, very important role. Dynamics. Right, so dynamics. Right, so madam, I think you are married, right? So suppose if she had a fight, if she had a fight with the husband, right? So before coming to this session, and ask her to put the attendance signature, the dynamics will be entirely different, right? So you'll be trying to express the angerness through your signature. Whose angerness? Your angerness on your husband, through the signature, right? So the stroke, the impact itself will be different. Right, so the dynamics really plays a very, very important role. Right, so using these dynamics, we can analyze the mood. Right, so we can analyze the mood. Right, so whether you are in good mood or something it's happening. Right, so there are so many things that can be done. Right, so through these dynamics and morphological analysis, I think this is what actually you have extensively done to the face, fingerprint, face, ear, iris, retina, hand geometry, hand veins, right? So still it goes on, it goes on, and it goes on. But all these needs, right? So all these needs something which is acceptable, right? So by the end user, right? So for that, right? So for that you need to really think of, right? So what could be the simplest thing that you can deploy, right? So to really manage with this, right? So these are really little easier, right? So little easier to capture, right? So these are little highly complex to capture, right? So these are intermediate, right? So these are intermediate, right? So people are not really going with any one type of an analysis, right? So people are trying to go with the multiple combinations, right? So people are trying to go with the multiple combinations, right? So probably the behavioral analysis, right? So the behaviors of a person, right? So could be merged with the morphological data, right? So such that, right? So that is where actually this word called multimodal or hybrid biometric methods comes into picture. Probably combining the gait with the face and face with the voice and signature with the retina and retina with the keystroke, right? So that becomes the next level of, right? So the next level of biometric authenticity, right? So but still people are not really satisfied with whatever the results that they are going to get, right? So but still they are thinking of this, right? So but it has got its own complexity, and each and every trait that that we have presented here has got its own complexity, right? So complexity in what sense? Complexity in its own sense, right? So in its own sense, probably we'll see. This is what actually I was told in the very beginning. The word security mechanisms are not really will really give justice for whatever the applications that you are going to build, right? So absolutely it does not give any kind of an security mechanisms, especially with the conventional using username and passwords, right? So something you are supposed to go with the advanced methods, right? So something you are supposed to go with the advanced methods, right? So maybe something called the liveliness, right? So liveliness of the biometric traits. What is liveliness of biometric traits? I think you might have seen in some of the movies and all, in the crime scenes, as soon as if one person is murdered, and if they want to open the phone, right, so they'll immediately run and they'll take the fingerprint, right? So they'll touch their fingerprint and the phone will get open and they'll do something else. But that is basically a liveliness, right? So the amount that it stays active, right? So the trait that remains active, right? So that is also considered to the best extent, right? So because that cannot be seen, right? So that cannot be seen in most of the biometric traits that whatever we are considering now, right? So because more or less whatever we are doing, right? So it's all basically the very conventional methods that what we are trying to deploy. I mean, we'll try to acquire, we'll store it in the database, we'll match it, then we'll give the results saying that this is person 1, person 2, person 3. Even in the real-time sense, right? So basically we should have an back-end database at least one time, right? So at least one time it has to be trained, right? So at least one time it has to be trained. Then only your machine will get to know, right? So then only your machine will get to know that this is what actually the trait that has been considered, right? So the trait that has been considered. Right, so authentication, especially in this digital area, right? So digital era, right? So these biometric traits, right? So are playing a very, very important role, right? So are playing a very, very important role, right? So you irrespective of whatever, right? So whether it could be a physiological analysis, or it could be a behavioral analysis, or it could be a morphological analysis, right? So these are the simplest characteristics that are expected. I think these are all covered more or less. That is the universality, right? So such that it is to be unique and distinct for each and every person, right? So distinctiveness, permanence, collectability, right? So it should be very easy to collect also, right? So it should be very easy to collect also, right? So collecting the biometric itself shouldn't be an challenging task. Right, so shouldn't be a challenging task, right? So it should be acceptable, and the performance, the overall accuracy and the speed, right? So it should be it should be so fast, and it should be acceptable, and ultimately acceptability, right? So no doubt you can you can capture the different types of you can capture the different types of the biometric traits, but it should always from the consent of the end user, right? So it should be always from the consent of the end user. That is point number 1, and that is acceptability, and the collectability should also be, right? So on the other side, it should be equally as simple as possible. A good example that I can give you is, this tip of the tongue is a biometric, right? So this tip of the tongue is a biometric. But is it practically possible to capture that biometric that trait as a biometric? Right, so can you show some device, you keep your tongue, I'll capture it as a biometric. Is it acceptable by any users, end users? Right, so but still it's a biometric. I mean unique. Right, so it's a unique. Right, so there is an always debate. Right, so there is an always debate that goes on. Right, so it's all it's only the debatable questions, but still it is acceptable, right? So but still it is acceptable. Right, so in that sense, the acceptability, collectability should be, somewhat, it should go hand on hand, right? So should go on hand on, and ultimately the universality, right? So it has to be accepted by each and every individuals, right? So it has to be accepted by each and every individuals, right? So these are all the different types of, biometric traits that are available. I think more or less this is being taken by Professor A.K. Jain's paper, right? So A.K. Jain's paper, and I think you might have seen this slide also, right? So you might have seen this slide also, right? So where depending upon the different biometric traits, right? So there are, I think there are 7 different, metrics that were considered, because you need to evaluate it, right? So to these particular applications, right? So this is what the trait that can be used, that can be used. A simple attendance system, you need not to go for signature. See, everybody is passing the sheet, right? So losing your attention, right? So losing your attention, right? So I don't expect that, right? So I don't accept that, right? So because in this case, probably if it is possible, right? So that what Professor Guru has designed that attendance system, right? So probably if you go with that mechanism, that is more than enough to capture the attendance of the class, right? So that is why the 7 metrics were considered, right? So but if you see fingerprint will give almost the best stability when compared to the other metrics. But see, the signature goes very weaker, right? So signature goes very weaker. So this is where actually, even if you, because since you are working on the signature biometrics, you should always keep in mind these, especially these kind of low, especially with respect to the accuracy, reliability low, and stability it varies, because whatever the type of signature that I was signing when I was in class 12, that signature doesn't remain same, right? So and people are there who used to go to bank every year and they'll get update their signatures, right? So it clearly says that the stability of the signature is lost, right? So stability of the signature is lost, and it also depends upon the emotion of the person, right? So emotion of the person, right? So the style, right? So the pressure, right? So the pressure, right? So there are so many things that are really, matters, right? So stability, reliability, I don't think, because people are talking something about the forgery and all. User cooperation is. In India, it's very simple to capture any kind of an, the traits that you want, right? So see, he is recording. With whom permission you are recording my audio or my class? Did you take my consent? That's the simplest question. Have you taken my consent? No, Mr. Manjunath has to answer. Have you taken my consent to record this class?
No.
No, he has not taken. Can you put your signature here? See, he is taking the pen. Put your signature and he will sign. Without giving a thought, he will do that. Because the only reason is we trust. That's it. Nothing else. Right, so but that is not acceptable. In many of the developed countries, so-called developed countries, right, so even it's not really acceptable. Right, so you cannot, without even a single permission, right, so you cannot even capture the videos, capture the images, capture the photos. Even if the kid is about to fall in the park, you cannot touch that kid. Right, so that is the type of law that they have. But see here, right, so simply he is recording my class and maybe he'll send to my management saying that this fellow doesn't teach properly, so you have to you just imagine the later part. But he has recorded that. Right, so he has recorded that, right? So that is what the problem that we are going to face. You all are feeling sleepy or huh? How many of you are feeling sleepy? Sikya? No. Prajna or Pragna? Anything is fine. Okay. Right, so this is all, the traits that we wanted to tell, right? So, but before taking the actual what exactly I want to discuss, right? So, if you just permit me, I have a wonderful video that why actually this came into, because of the two reasons, right? So, it's all 50 minutes of talk andre, it automatically triggers that your session ends, right? So, because of the timetable, right? So, 50 minutes class, point number one. Point number two, right? So, we need to have a break, but madam is not giving the tea, right? So, point number two. And point number three, obviously at least 5 to 10%, right? So, we'll be feeling sleepy, right? So, just to avoid all these three things, right? So, I have one small video, right? So, it is worth watching, right? So, I think you might have watched somewhere else, but I think it's fine. It's fine. ಸಾಕು ಏನು ಡಿಸ್ಟರ್ಬ್. This is basically taken from NSF.
The combat zone to the corporate office, from the airport to the ATM, knowing who's really who is a big security concern. Traditionally, a person might enter a password or pull out a driver's license or passport as proof of identity. But increasingly, identification and authentication can also require an eye scan or a well-placed hand. It's a science known as biometrics, recognizing individuals based on their physical or behavioral characteristics. The structure of the face, the geometrics of the hand, the ridges of a fingerprint, the patterns in an iris. Every person carries multiple human traits that are a unique form of personal identification.
The primary advantage of a biometric trait is that it belongs to that individual.
I think especially from University of Mysore, I think you might be knowing is Professor Arun Ross. Right, so basically he worked with Professor Jain, Anil K. Jain, and now he's in West Virginia University. So Professor Ross is considered to be the pioneer in the field of biometrics, along with the collaboration of Professor Anil K. Jain. Anil K. Jain still works for MSU, Michigan State University, and he moved to West Virginia University. And more or less, they have not left any of the traits in the world which is considered to be as a biometric. Right, so and another, the two reasons that why I am telling is the level of research that they have done, point number one. And point number two, basically these two professors are from India. And 95% of the North American airports runs only the algorithms that are designed by these two professors. I mean team, Arun Ross and Anil K. Jain. So,
And Anil K. Jain sir was also the part of our Aadhaar.
Yeah, correct. Right, so he is the advisor.
You're implicitly connected to it. Unlike passwords or tokens or passports which are external to an individual.
Arun Ross is a computer science and electrical engineering professor at West Virginia University, one of 3 institutions where the National Science Foundation is helping to fund a coalition of biometrics research sites. The Center for Identification Technology Research, or CIDR as the coalition is known, is an example of the important role that public and private funding can play in the innovation process.
The National Science Foundation does offer seed funding, but that is augmented with the funding from these corporations and government agencies.
CIDR affiliates funded Ross's 2005 research with Dr. Reza Derekshani, who was at the University of Missouri in Kansas City.
He is direct, so who is another very important researcher, especially who has given a breakthrough that for whatever the topic that we are going to discuss, maybe the next minutes of time, because they were the one who really coined that this can be considered as another very interesting biometric, and which gives more meaningful results when compared to the conventional existing biometric. So that is what actually they wanted to say.
Iris recognition systems process the full iris, so when the eye's gaze is off-center, only a portion of the iris is seen, and recognition is hindered. Ross and Derek Shani proposed the idea that the sclera, the white part of the eye, might be an additional biometric trait that could be used for identification.
We asked ourselves, what type of information can we extract from the sclera in order to perhaps improve the performance of classical iris-based systems?
First, Ross and Derek Shani collected digital images of eyes from dozens of subjects. Then they separated the sclera from the pupil and the iris to search for unique features.
We began to see the features that were on the surface of the sclera, but also on the conjunctival vasculature, the vein pattern that is evident through the sclera. So we started developing algorithms that can be used to extract features.
Computer algorithms are step-by-step instructions that tell the computer what to do. With fingerprint recognition, they are used to extract features called minutia points, the unique points in the fingerprint ridge where it ends or splits in two. With iris recognition, they convert the unique iris patterns into a binary code made up of zeros and ones like a barcode of the eye.
So when we say algorithms, really we're talking about image processing algorithms. Algorithms that the computer program can use in order to extract features that can subsequently be used for matching purposes.
With sclera recognition, the algorithms extract features from the sclera surface and vein patterns.
So I think probably if any one of the researcher might have discussed something about the patterns, right? So the patterns, especially with the palm vein and the hand vein geometries and all, right? So here also they have just extended that whatever they did, because hand geometry and the palm vein were considered to be the previous trait that was proposed in the field of biometric. Right, so they extended the same thing here. So they extended the research that was done, especially for the fingerprint, because fingerprint. If you take the fingerprint, the one of the very fundamental feature that can be considered out of any fingerprint is a minutia point. Right, so minutia point is basically where two points will get connected. Right, so that is what actually they have plotted here. You can see here, right? So the green dots. Right, so the same concept has been extended to this, right? So because this is considered to be a very fundamental research. Now there are many advancements that has been taken place, but this was the fundamental research that they have taken, and the same vein pattern that whatever they captured, right? So with the hand geometry and the palm vein, right? So along with the minutia points that has been extracted in the fingerprint. The same has been extended to the sclera. So that is what actually they want
As
to
they
say.
hoped, the sclera proved to be useful in identification.
See.
Blood vessels, like fingerprints, remain stable throughout life. The computer program was able to compare and match this information.
We began to notice that the similarity between two images of the same person was much more than between two different individuals.
The university's help, Ross and Derek Shani filed for a patent, which was granted by the United States Patent and Trademark Office in 2008. Simona Quijelmeano, a research associate on Ross's team, based her own research on the patent, developing different ways to extract and match features found in the sclera.
I think she has really contributed in taking this research to the next level by developing new algorithms for feature extraction and matching, as well as the possibility of combining the iris with the sclera.
The research also caught the attention of a commercial venture, iVerify, which has licensed the patent for mobile applications.
We have to keep moving forward, looking at new ways to solve old problems, because what was unsolvable a few decades ago might be solvable now.
Solving old problems takes innovative thinking, and because of dedicated funding, researchers like Arun Ross have been able to work on new solutions with an eye for the future.
Okay, so this is one very interesting, the work that has been attempted by the Arun Ross team. maybe you can just go to Google, right? So and see the different sets of papers that has been come out with exclusively for the Sclera trait. So that is how actually they initiated or the market got to know that there is another trait called the Sclera, right? So there is another trait called this Sclera, and it was a very recent research. Probably the 2007 and 2008 was the a breakthrough. So hardly it is 12 plus 3. So it is just a 15-year old research, right? So when you compare to the other research like fingerprint or face or even voice, etc. Gait is considered to be a very old 1970s, right? So I think this is what they were trying to explain, that this part, right? So this is basically an iris, right? So this is basically an iris, and if you see the anatomy of the eye, the three important regions, right? So plays a very critical role. That is the pupil, right? So the pupil is really little complex to touch upon, right? So pupil is really little complex to touch upon, right? So then iris is quite very simple, right? So the iris is simple, and people have done an extensive work in the field of iris, right? So till 2007 till 2008. I think as Professor Arun Ross said, right, so they were not really happy with whatever the results they got by the iris. They want something else, right? So they want something else, right? So probably everybody knows Kannada here, right? So they ಒಂದು ಕಲ್ಲಲ್ಲಿ ಎರಡು ಅಕ್ಕಿ ಹೊಡೆಯೋದು ಅಂತಾರಲ್ಲ. So the same thing. That is what actually they they got the breakthrough. What is that breakthrough? So the capturing is very simple here, right? So it's just they are trying to capture the iris part, where already the acquisition devices are deployed, right? So the acquisition devices are deployed, but here rather than working or trying to capture only the iris part, right? So they have gone one step ahead and they just try to see this white part, right? So in the eyes, right? So that is called as Sclera, right? So that is called as Sclera, right? So the beauty of this Sclera is this. Right, so the beauty of this Sclera is this, right? So especially the iris, right? So the iris requires NRI, right? So what is NRI stands for? NRI illumination, especially to capture the iris. So that is why I think you have seen, if you go to capture the Aadhaar card, right? So if you want to get your Aadhaar done, right, so you need to place your eyes with one device. So that is basically an NRI illuminated camera. So that is the requirement there. So is it low cost? No, it is not low cost, because you need to deploy something, right? So where you are supposed to spend on NRI illuminating devices to acquire the iris. But if you see Sclera, right, so if you see Sclera, right, so Sclera is something which is very interesting, right? So where even it doesn't require, right? So even if it doesn't require that NRI illumination, right? So if you just try to capture your eyes through the one of the best phones that are available, and people are talking something about more than 48 megapixels, Manjuna?
Yeah.
More than that, I
We
guess.
have cameras.
No, especially with the mobile phones, I think more than
48 megapixels.
Right, so more than 48 megapixels, you just see the clarity of the information that you will get, right? So at your eyes, right? So at your eyes, right? So if you get that, then that is, anything to share?
So she is feeling scared that ಇದರಿಂದ ಕಣ್ಣಿಗೇನೆ ಎಫೆಕ್ಟ್
100%
No.
No.
It's very low radiation.
No, 100% no. So otherwise they don't allow to deploy to the regular publics, right? So if they found something which is destructive to your eyes, they don't do. And as Madam rightly said, Anil K. Jain also is the part of this UID, that is other program, right? So that is, and unfortunately during that time, right? So it was when did this Aadhaar came? I think 2012, 12. Yeah, 10, 11. I think it was the Congress government that who started this. So Modi was almost for 2 batches, it's almost 2010 to 2011. So during that time, even though Anil K. Jain, right, so was knowing that this could be the best breakthrough, right, so to go through with this Sclera, but it was not accepted to the expected level, right? So that is why he didn't touched upon, right? So nor the Arun Ross team recommended to use these Sclera along with the iris, right? So for your Aadhaar card, right? So for your Aadhaar card, but now it's more advanced now, right? So it's more advanced now, and you can definitely propose to make use of this method, right? So another very interesting advantage of this Sclera is, right? So you do whatever you want, right? So you apply kajal, you apply something ear, eye drops, lens, you do whatever you want, right? So the best part of the Sclera, it remains same, right? So it remains same. Even there is an existence of the occlusion, right? So occlusion is possible probably because of the tears that has been generated at your eyes, right? So even if there is an water content in your eyes, right? So but still the Sclera is able to capture to the best extent, right? So other factors like aging, right? So from day one, right? So to the last day of an human being, right? So the Sclera, the pattern, veins remains same. Makeup, right? So you do so many things, right? So you do so many things, right? So even if you do so many things to your eyes, right? So if to your eyes, the Sclera remains same. And this is something which is very debatable, right? So because I'll tell you maybe at the later point, right? So that why this third point, right? So is debatable, because I used a word called practically impossible to alter or replace the eyes, right? So but the trend is getting changed, right? So the trend is getting changed, right? So the trend is getting changed, and they'll try to replace nowadays with the different with the organ replacements and all. Probably at that time, with the intervention of a human doctors, we need to evaluate it, right? So that is the next level of research that we can really think of, right? So I think in Karnataka it has become a trend now after this Puneet Rajkumar's death. Everybody is trying to donate their eyes, right? So what level of the organ that has been deployed to the other person, right? So even that is the debatable. So you please make it in a star, right? So especially this third part, because it is also nearby impossible to spoof this Sclera image. I really don't endorse this statement, right? So I really don't endorse this statement because it is a debatable, right? So because it is a debatable. And as the last advantage says, it's a very simple trait that can be fused with any biometric, right? So maybe iris can go with the Sclera. Your face can go with the Sclera. Suppose if you wear burqa, right? So if you wear burqa, right? So you'll get only eyes, right? So you will get only eyes. You need not to tell to open the burqa. Right, so then you can just try to capture this. That is more than enough, right? So you'll get everything, right? So you'll get Sclera, you'll get iris, right? So and etc. Right. So the challenges, yes, still there are some challenges, right? So capturing precise segmentation of the Sclera region. So this is a very interesting topic to work on, right? So because Sclera, extracting Sclera, the white part in the iris, right? So it's not as easy as we think. Right, so even though the acquisition is very simple, but the segmentation part is a very challenging task. Right, so we can spend some time, extensively on that. And second one, vessel patterns. Right, so I should not tell this, but still, it could be taken as just to trial and error basis. You try to think of all the algorithms that are deployed on the hand vein patterns. Right, so hand vein patterns, more or less 70 to 75% of the algorithms will work out fine. Right, so 70 to 75% of the algorithms work out fine. The reason is very simple, because here also, after all, you are trying to capture the vessel patterns. Right, so we use a word called vessel here, but they'll use a word called vein pattern. Right, so they'll use a word called vein pattern. And mining discriminative features, right? So is little tougher task, right? So because you need to come out with some kind of a discriminative model, right? So which which really discriminates, right? So from one set of an sclera images to another set of an sclera, and this is the real challenge. This is the actual real challenge that we are going to face, right? So that we are going to face, especially during the acquisition phase, right? So the eyelashes and the eyelids, right? So as soon as any destruction comes, right? So without the fraction of seconds, right? So we'll blink, right? So we'll blink, right? So if you blink, definitely the eyelashes, right? So and the eyelids, right? So will plays a very crucial role, right? So will plays a very crucial role. I think some of you might have experienced, right? So while giving the other card, right? So you'll go and sit and you'll open your eyes. Sometimes you are not able to tolerate that, right? So and you'll come back, right? So again you'll tell, Madam Sarik bandila, bani mudde idon sali kodi. So that is all because of your the some kind of a distraction that takes place, right? So that comes in front of your eyes, right? So and it happens within the fraction of seconds, right? So within the fraction of seconds, and we cannot expect any end user, right? So open your eyes like this and give the trade. We cannot do that. We cannot ask them, right? So we cannot ask them, right? So if that is the case, you just think about Chinese, right? So you think about Chinese and Koreans, right? So their eyes is so small like this, Tibetan, right? So their eyes is like this, so small like this, right? So I don't know whether they'll sometimes they'll be, even if they're sleeping in the class, right? So nobody will get to know, right? So that's the tough task, right? So that's the tough task. So that is why Chinese has not touched upon this area very best, right? So the maximum contribution is done by US and Australia, especially for this trade. Chinese little contributed, right? So a little contributed, and a modification of texture, texture patterns. I think instrumentation people will really know about these very interesting characteristics like attenuating and attenuating. It's very interesting, characteristics when you try to convert this trait pattern into a signals, right? So when you try to, I mean that is the another very interesting work, right? So where rather than working, giving a simple mathematical representation, try to make it more complex, right? So try to make it more complex, but ultimately the objective should be, you should say, that this is the model that I have designed and the best model that I have designed, right? So for such kind of a research, right? So yes, this really plays a very important, role, and the computational resource, right? So especially from the point of performance, right? So the extraction, right? So you need to give a lot of scope towards the extraction, right? So you need to make sure that the full white pattern is acquired, right? So full white pattern is acquired, right? So then you should really think of best out of best representation, right? So best, I mean, when you see 2007 and 2008, they started with the binary representation, but people don't accept the binary representation. It's gone, right? So people are talking something about the huge mathematics, right? So that has been embedded, right? So to this kind of an trait, and ultimately, the matching. Professor Guru sir was telling something about the indexing and retrieval, right? So how best you are going to index, right? So how best you are going to index, right? So best or so fast you can retrieve. That could be really one of the best research work that you can really think of. You take it from me, right? So that is the one of the best research work that you can think of, right? So you can just think of implementing all the trees that exist in the literature. That will become a pure core computer science research. Implementation of all the data structure, right? So you take a trait, right? So you take a trait like Sclera, right? So and you try to run through all the data structure and you index it, right? So you see what is the retrieval time, and you showcase. See, if you use this tree, for example, if you use KD tree for this Sclera, this is what the result that you are going to get. Then that could be a wonderful contribution that you can make to the research community, right? So see, you have achieved many things. You have worked on core fundamental computer science, right? So you have showcased something which should be taken and which should not be taken, because the research is not only to tell that this is what actually you should do, you should also tell what not to do, right? So you should tell what not to do, right? So that is the best research that you can really think of, right? So you think on those lines. Don't do that. Don't take R tree, right? So because this is what the time that it is taking. Don't use KD tree because this is what the time that it is taking, right? So you use Z tree, right? So see the Z tree, this is what the best results that you are getting, right? So and she used something called low cost. Can your algorithm should be so optimized such that, right? So the indexing algorithm takes a very minimum time, index it, retrieves at a faster rate, and showcase that this is what is Sclera that belongs to, right? So these are some of the challenges that you can really think of, right? So another very important thing that I wanted to say is Aadhaar card. Yes, we definitely we passed that time, right? So we passed that time because of the reason, right? So it was at the very initial stages, 2007 and 2008. But the beauty of this Sclera is, right, so which is not really captured. I don't know whether it is captured in any of the future slides. Twins, right? So twins cannot have the same Sclera. That is one of the beautiest characteristics of the Sclera. Another very interesting characteristic of the Sclera is the pattern that you are going to see with the left doesn't matches with the pattern that you are going to see at the right. Right, so what kind of discrimination you did in order to identify that this is me? That is more than enough. Right, so you see, even twins, suppose if you think that, twins will have same, no, even twins doesn't have a same Sclera set. And if you take your own Sclera, the left patterns, right, so the Sclera of the left patterns doesn't match with the Sclera that you are going to find in on the right side, okay? So this is a simple, block diagram, right? So for the personal authentication that we did, especially at our lab, I don't think it is really needed to discuss in depth. It is all self-explanatory, and you can do so many things, at each and every, module. Pre-processing, there are so many methods. Sclera segmentation, there are so many segmentation methods that are available. Enhancement techniques, right? So there are so many image enhancement techniques because after all we are trying to take the Sclera as an image. Feature extraction, you can think of so many different number of features, right? So to handle the Sclera, build a good knowledge base, that is nothing but the database training set, I mean to say, right? So I mean to say training set, right? So then go for the best out of best recognition algorithms, right? So which gives more meaningful authentication for a person who is trying to get matched with the end user, right? So these are the two standard data sets, right? So I'll try to take these at the later stages, right? So SSRPC 2017 and 2019. Why did we coin 2017 and 2019? Because though after 10 years of time, right? So even though after 10 years of time, there was as such any standard database that is built exclusively created to handle the Sclera, right? So this is the I mean to say this is the best efforts that they have made in 2017 and 18. Hardly it's just a 5-year-old research, right? So 2017 and 2019, right? So SSRBC, which is an exclusive group of people who works exclusively on this, right? So who works exclusively on this, have created this database. But you can see major problem with this is this, right? So major problem with this is this. What is that? 2624 images. After all, it is a very minute, right? So you don't have such and sufficient database that has been created, and created using how many number of
82
individuals. Hardly 82 individuals, right? So hardly 82 individuals. So why I'm stressing on this slide is because the scope that is available, right? So the scope that is available in this thread, Right, so this I just try to, now you will see some mathematics where you'll feel, much more sleepier, right, so where you'll feel much more sleepier, right, so because, you'll feel like that, if you leave out anything, at least any one parameter, it more or less that you'll be watching like a German or French film, right, so on the slides, you won't understand anything, but it's a very, very dummy and simplest mathematics that we have used. Right? So it's a very simplest mathematics that we have used, and where we have achieved the best set of results. Right? So I think image enhancement technique, even if you open the Rafael Gonzalez, right? So which is considered to be one of the best book for image processing, you'll start the image processing topic, right? So with the introduction, and second chapter obviously it will be on image enhancement. I think first chapter it's more or less about the acquisition of the image. I think he has given an eye picture, right? So he has given an eye picture, and how do we see the same thing is simulated in the camera, right? So then so many things takes place. Then the image is created. Once the image is created, no, you are not really happy with the image that you have created, but you need to enhance it, right? So that is the second chapter, right? So see, I think I need not to spend much time on this. Histogram equalization, do you want me to talk about this? Histogram equalization is, it's just trying to convert an image into an histogram representation. Right, so histogram representation. One is HE and another one is Sclera. Sclera is another very, little advanced. I don't say it's an advanced, right? So just when you try to compare to the conventional histogram equalization, just another little advancement, right? So that is contrast limited adaptive histogram equalization. The catch in this is this adaptive, right? So it tries to capture the very interesting discrete features, especially if you use the clay, right? So and they used basic clustering as an segmentation techniques, right? So clustering as a segmentation techniques, right? So this is what the explanation that has been given. Right, so especially with respect to the histogram equalization and the clay, right, so more or less we'll try to play with only 0 to 255 pixels, that's it. Right, so even here also we have done the same thing. Right, so even here also we have done the same thing, but with the 255 pixels we achieved what we want. Right, so with the 255 pixels, right, so we achieved what we want. So this is what actually we want, and this is what actually we achieved it. Right, so now I don't think so this is little complex to handle. Pragna? This is as simple as drinking a cold coffee. Right, so if you know the basics of image processing. Right, so if you know the basics of image processing, right, so it's handling this histogram it's as simple as anything. Right, so but see, the beauty of this is, right, so the beauty of this is between these two, there you can see it little, the image, right? So it's on the darker side, right? So it's on the darker side. But here we have enhanced it, right? So how do you enhance? You use enhancement techniques, right? So you use enhancement techniques, and you see the histogram that is obtained, right? So for the input image, right? So you see the input image that we have. The histogram that we achieved for this is more discretized, right? So this is more discretized, and since this is more discretized, I think at this point is more than enough to say this is the best characteristics for this Sclera. Yes or no? Yes or no, please? Yes. Right. So that is more than enough. Right. So and this is a little more clumsy, kind of, where you put lot of makeups to your eyes. Right, so tears are there, right, so there are so many things that has taken place to this, Sclera, and once you project it, this is what the, kind of histogram that you will get. But we played with only a simple histogram and clay, right, so simple histogram and clay. And doing this, right, so doing this, there are so many results that they achieved, right, so they have achieved so many different sets of results that they achieved, but because we want to showcase, right, so if you just use the histogram equalization and the clay, right, so it's more than enough for me to segment the required part. So how to showcase that? Try to use any one of the segmentation techniques that are available. There are so many different segmentation techniques that are available. Even if you refer Rafael Gonzalez, there is one chapter called image segmentation. Right, so there are so many different types of segmentation techniques. Among them, the best one could be the cluster-based segmentation technique. And out of best cluster-based segmentation techniques, we have used K-means. Right, so he has used K-means. Right, so and out of K-means has got its own limitation. Unfortunately, you know that. Right, so because that is the fundamental clustering algorithm. So to overcome that, they have used fuzzy C-means. Right, so they have used fuzzy C-means. Right, so the whatever the limitations that we saw here, right, so has been overcome, in using the fuzzy C-means, and the results are targeted. Right, so and the results are targeted. Right, so this is for the different data set. Right, so just out of 82 individuals with 2,224 images. Right, so this is what the results they achieved. Right, so obviously it is well accepted because even the database is very minimum. Right, so very small size of the database. Right, so and the technique that you are using is also very simplest. Right, so after all you are trying to convert an Sclera into an histogram. Right, so and you are trying to discretize. Right, so and you are trying to play with the the high discretized value of the histogram. Then you use a simple clustering method as a segmentation and try to achieve these results. Right, so these are some of the results that they have achieved. Right, so okay, so this is the first work that we attempted. So then we were not really happy with the we were not really happy with the conventional K-means clustering and the fuzzy. Right, so conventional K-means and the fuzzy. K-means already because it has got its own limitation. Fuzzy also has got its own limitation, but we try to play with the kernel. Right, so we try to play with the introduction of the kernel, where the introduction of the kernel, has given a dent. Right, so for the best results. Right, so for the best results. Right, so among them there are so many different clustering methods that we really explored. Right, so and more or less all the segmentation techniques. Right, so that too with the different flavors of fuzzy. Right, so with the different flavors of fuzzy. Right, so has achieved the best results. Right, so among them the two things that we'll try to discuss. So one is even because the time is another 30 minutes, right? So we'll try to explore some of the very interesting aspects with JSKFCM and MIFCM, right? So where we have introduced the spatial kernel fuzzy segments, right? So and then we have also introduced the intuitionistic fuzzy segments. So what are these basically, and what is the difference that you can see with these conventional K-means and the fuzzy segments? Especially in the in case of generalized spatial kernel fuzzy segments, the introduction of the spatial information, that is very important because the placement of the patterns, right? So and the connectivity of the patterns, right? So that plays a very unique characteristics for any Sclera. So that is point one. That is where actually it has been captured, right? So especially with the spatial kernel. But we were little eager, frankly speaking, we wanted to explore to the what level the fuzzy, right, so what is basically fuzzy?
Uncertainty.
Uncertainty is,
Between 1 to 3.
uncertainty,
Not a fixed value.
not a fixed value,
May or may not.
ambiguity.
Ambiguity.
When does this arises? When does this arises?
This is neither
tries
yes
to
or
put
no,
on to-
in between values.
No. When does this arises?
When it belongs to more than one class.
See, you have 4 girls. You have to pick only one. So what do? Chandrasekhar? PhD?
Please take someone else.
Please. Not you. Oh, you are scared of girls, huh? There are 4. 1, 2, 3. Your mummy will show you. See, Papa, these 4 kids, 4 girls, sorry, not kids, 4 girls are there. You have to pick one. See, options, 4 options. Whatever you are going to see in option 1, right, so probably it's very different in option 2. Which is more likable? And the same thing is acceptable in the option 3 also, which is once again which is very close to your art. And the same thing with option 4. Then what do you do?
Depend on his.
But he likes all the 4 characteristics. That is the problem.
There will be some disorientating.
Right. So more are the option, obviously. More are the options, obviously more are the confusions. Right. So as she said, more are the ambiguity. Right. So as she said, more of the uncertainty. Right. So uncertainty in selecting. Select ಮಾಡ್ತೀನಿ ಅಂದಾಗ you will become 32, 33, 34. Right. So because of too many options. Right. So because of too many options. Right. So the same thing happens. Right. So you take any problem for the matter. If there are too many number of options, obviously there will be more, kind of an uncertainty. But here it's not the question of only the uncertainty. Here the question is how you capture this uncertainty is also really matters a lot. Right. So maybe she'll pick option 2. Right. So maybe she'll pick option 2. Right. So who is more closer to his heart? But she'll try to train her such a way that the characteristics that what he has seen in option 1, option 3, option 4 can also be inculcated in option number 2. Fine? That is acceptable? ಅದೇ ಮ್ಯಾರಿಡ್ ಲೈಫ್ ಅನ್ನೋದು ಅಷ್ಟೇ ಲೈಫ್ ಪೂರ್ತಿ ಅದನ್ನೇ ಮಾಡ್ತಾ ಹೋಗೋದು. Right. So that is how actually the more of the ambiguity will be captured. Right. So that is how actually you are trying to capture the more of uncertainties. Right. So why I told this is because we were really a little eager, right? So to think beyond uncertainty, and also we were very much interested how to capture this uncertainty. So that is why this this intuitionistic fuzzy sequence. Right. So but there could be a question. Right. So ನಿಮ್ಗೆ ಯಾಕೆ ಈ ಥರ ಯೋಚನೆ ಬಂತು ಅಂತ ಕೆಲಸ ಇರಲಿಲ್ವ ನಿಮ್ಗೆ ಏನು ಮಾಡೋಕ್ಕೆ ಈಗ ಆಲ್ರೆಡಿ ಚೆನ್ನಾಗಿ ಬರ್ತಿತ್ತಲ್ಲ ರಿಸಲ್ಟು ವೈ ಯು ವಾಂಟ್ ಟು ಎಕ್ಸ್ಪ್ಲೋರ್ ಅನ್ನೆಸೆಸರಿಲಿ ಅಂತ. ದಟ್ ಈಸ್ ಬೇಸಿಕಲಿ ರಿಸರ್ಚ್. ಏನು ಗೊತ್ತಿಲ್ಲ ಅಂದಾಗ ಅದನ್ನೇ ರಿಸರ್ಚ್ ಮಾಡೋದು. ರೈಟ್. ಸೊ ವಾಟ್ ಈಸ್ ದಿ ಸಾಲಿಡ್ ರೀಸನ್ ಟು ಕಮ್ ಔಟ್ ವಿತ್ ದಿಸ್? ರೈಟ್. ಸೊ ಇಸ್ ದೇರ್ ಎನಿ ಸಾಲಿಡ್ ರೀಸನ್? Then once we implemented and saw the result, then we add a justification. Oh, ಹಿಂಗೆ ಮಾಡಿದ್ರೆ ಹಿಂಗೂ ಬರುತ್ತೆ. Right. So that is where actually we achieved. Right. So but still during the initial phase the motivation was very much minimum. Just we want to explore the more of the greedy. Right. So greediness, and we wanted to explore the level of uncertainty that can be captured. That was the only intention. Later we could really capture that how these two played a very important role, especially with this, because our talk started with this. Right. So our talk started with the optimization. These two really gave benchmark results. Right. So for this optimization. Right. So I mean, don't worry about this. Right. So nothing to really bother too many about ಈ ಥರ ಶೇಪ್ ಎಲ್ಲ ನೋಡಿದ್ರೆ ಒಬ್ಬೊಬ್ರಿಗೆ ಹೆದರಿಕೆ ಆಗುತ್ತೆ. ಹಿಂಗೆಲ್ಲ ನಥಿಂಗ್ ಇಸ್ ದೇರ್. ಅದು ಗೊತ್ತು ಸಮೇಷನ್ ಅಂತ. ಹಿಂಗೆ ಕೂತ್ರೆ ಇಂಟಿಗ್ರೇಷನ್ ಅಂತಾರೆ. ವೈ ದಿ ಸಮೇಷನ್?
Adding.
You can also integrate it, right? Why the summation? Adu answer. Why not? Both are same, right? Correct. You are right. Right. So we are not really. I mean, not we. Right. So even human brain is designed to work on the same principles. You should go with the discretization. Your brain. Right. So your brain also go with the discretization. Otherwise what will happen? No, you'll go mad. Definitely your right answer, you'll go mad. Right. So you are in still 7th standard, 8th standard ಅವ್ರನ್ನೇ ನಿಮ್ಮ ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿದ್ರೆ ಹೆಂಗಪ್ಪ ಜೀವನ? Right. So your life will become too tough. Chandrasekhar. Right. So if you just keep on your 8th standard friend, 9th standard friend in your brain and thinking of getting married, right? So you'll go mad. Right. So you should discretize it. You eliminate it unwanted. Right. So that is why this discretized value here. Right. So and this is basically a kernel function. Right. So what is kernel basically? Any simplest answer?
It is
Art.
Window.
It is a window. ಒಬ್ರು ಹಾರ್ಟ್ ಒಬ್ರು ವಿಂಡೋ ಆಮೇಲೆ ದೆನ್ ವಾಟ್ ಕುಡ್ ಬಿ ಸಿಂಪ್ಲೆಸ್ಟ್ ಡಿಕ್ಷನರಿ ಮೀನಿಂಗ್
Form of representing.
threshold no not exactly threshold. What is basically simplest kernel is that what you are seeing here, right? So but what is basically a kernel? What is basically a kernel? Madam, kernel has failed really today because I got to know that yesterday only, right? So rather than starting the class at 9:30, let us start at 10 o'clock. The strategy is such that we'll give a chance, fair chance to the participants such that they'll have a breathing time of 30 minutes extra. Right, so that is basically a strategy. Right, so we waited for 30 minutes and the crowd turned up. Right, so and the crowd turned up. So that is basically a strategy. You mean to say the kernel is basically a kind of a strategy that you try to do. Right, so maybe she said something called heart. Right, so heart al madakagala strategies na. Right, so you should do it in brain. So never ever propose any boy from the heart. Always try to propose from your brain. Right, so all the strategies should come from your brain. Not, oh, you married, huh? Chandrasekhar?
No, sir.
Right, so you try to propose from your brain, not from heart. Huh? So because your brain can strategize the things. Right, so we just strategized here and we have introduced this as a kernel function here. And what is this? We added with, come on, what is this? The simplest? Correct, you're right. Correct, you're right. Yay.
Weights.
You're right. No, no, it's not weights. No, what is this basically? What is this?
Dimensions.
No. Chandrasekhar, why me sir always? See here. This is basically a distance function, that's it. This is the simplest distance function. Then what could be the simplest distance function you can think of? Huh? Huh?
Euclidean distance.
Right, so Euclidean. Right, so Euclidean, but unfortunately Euclidean doesn't work out. Right, so because of the reason, I will show you in the next class. So that is why ultimately our strategy, Prajna, right, so is to bring down this objective function. Right, so is to bring down this objective function. I mean to minimize this objective function, right, so such that the ambiguity is reduced to the best extent, right, so such that the ambiguity is reduced to the best extent, and the more of expected level of patterns will get enhanced, right, so will get enhanced. So that is the beauty of, introducing the spatial kernel fuzzy signals. But the characteristics that you are going to consider is the spatial information. But please underline, they are not just only the spatial information, but they are weighted spatial information. Right, so what are weighted spatial information means? If Chandrasekhar sits here, he has got its own weightage. If Chandrasekhar comes and stands here, he has got its own weightage. If he goes to the research lab, he has got its own weightage. Right, so depending upon its spatial locality, right, so spatial locality, right, so the weights, it's getting changed. Right, so that's it. We have not done anything. Right, so this is what we computed the membership value, and this is the neighborhood function. Right, so why we want to compute the neighborhood function? Because we wanted to see the pattern existence. Right, so from one coordinate to another coordinate. Right, so this is a simple neighborhood function that we can think of. Right, so that we can think of. Right, so if you just refer a simple Gonzalez textbook, what could be the simple neighborhood function that you can think of? HSN ಹೇಳ್ತೀನಿ. What is the simplest neighborhood function that you can think of? Correct. You are right, absolutely right. Right, so it's a simple 2 cross 2, or as madam said, it's 4 pixel neighborhood information, or it could be 8, or it could be right, so it goes on. Right, so it goes on. Right, so that's the simplest neighborhood function that you can think of. So we have not done anything which is really something, a benchmark or breakthrough research here, right? So the only thing is we have just strategized here, right? So we have just strategized here. And now, because all we are trying to do is basically a segmentation technique which uses clustering methods, right? So clustering methods. But as everybody knows, clustering is basically unsupervised, right? So clustering is basically an unsupervised. So since it is unsupervised, you need to pick one point, right? So to compute the, no, to compute the, no, to compute the what? ಈಗ ಮಾಡಿದ್ವಲ್ಲ ಹಿಂದೆ.
Distance.
No. To compute the what? To compute the neighborhood information, right? So
How do you use clustering for neighborhood?
see, you pick one, estimate the distance from 1 to 1, right? So if he is more associated, the proximity lies between you and you, put it into an one group, right? So it doesn't lies here, right? So maybe I'll take Prajna, right? So she is the distance between the proximity between you two are more, right? So are more inclined, right? So you put it in one cluster. Yes.
Sir, actually this K value, whatever you will say, no, sir, this K value is directly, experimentally, you have explored through elbow method, or else that you have checked with the range of all from 2 to it by varying it.
Okay. So that is very the fundamental question, right? So because she is more worried about the value of K,
Yes.
right? So she is more worried about the value of K, right? So usually the K can be estimated in different ways, right? So still, you know that, everybody knows that if you try to come out with a mechanism, or if you propose any model, or if you propose any method such that if you use this method, this is what the K results that you get. If you do this research, you will get one PhD, right? So definitely you will get one PhD. So that is why even still today, right? So even still today, as such, there is no mechanism to say that this is how actually the K should be defined, right? So it's all basically an empirical evaluation, right? So it's all basically an empirical evaluation. Probably we have also experimented with the different even number combinations and odd number combinations, right? So you can do many folds. They are called as folding mechanisms, right? So K-fold methods, right? So even you can use that. But as such K, we don't have an answer, right? So we don't have an answer. So that is why, Chandrasekhar, what I did is I picked you as a center point, right? So I picked you as a center point, and I need to find out the neighborhood. How to find out the neighborhood? Just simple, right? So you try to pull the next person, find the distance between you two, right? So they are not really matching.
So we can use kernel also.
You can use anything. Kernel is basically a simple distance function, right? So the simplest the simplest kernel that exists in this world is the distance function, right? So how close you both, right? So you just try to compute the distance. That is more than enough. That will give, right? So and sometimes it is much beyond. So that is why people used to say that they are not happy with the similarity values, nor they are not happy with the dissimilarity values, right? So people are not happy with the similarity values nor dissimilarity values, but people are thinking something like the proximity values, right? So the proximity values are the proximity special work madi, right? So they will try to estimate from 1 to 1. So that is why there is an breakthrough research that took place, right? So by introducing a concept called MSVs and MDVs. MSV stands for mutual similarity value. MDV stands for mutual dissimilarity value, right? So whatever the level of friendship that you show to this person, right? So the same thing cannot be expected by the other side. So try to compute the mutuality, right? So try to compute the mutuality, right? So that is how actually, now I was telling you about the center point, right? So I picked one randomly, but is it the right way to do it? No, because that could be a very expensive process, right? So that could be a very expensive process, and it simply depends upon the trial and error basis. I pick Chandrasekhar, no, he's, he'll never ever converges. Whatever I say, he'll simply diverge, right? So can I go with Bharti madam? No. She'll also, right? So she'll simply diverges. I wasted 2 iterations. Can I go with Vani madam? Yes, Vani madam will converge with me. See, I picked Vani madam as a center point, the 3rd iteration. But what is the loss there? The loss is 2 iterations, right? So I already lost 1 iteration for him, and I already lost 1 iteration for madam, and the 3rd iteration, Vani madam has become an center point to me. So myself and Vani madam has become close now. I mean neighborhood function, right? So then I need to estimate the 3rd point. See, once again the randomization comes into picture. See whether Arshita madam goes with Vani madam, or Prajna madam goes with Vani madam, or if I take me, shall I go with this person, or shall I go with this person, or shall I give with this person, or shall I go with CKR? Right, so there are so many combinations that you can think of. So this is basically where you will try to control through some sorts of a strategy, and this is basically a kernel strategy. Right, so and this is basically a kernel strategy, and this is what actually we used, right? So to find out the best cluster center, but we are not claiming that this is the best method, and it cannot be best method also. Right, so even Anil K. Jain and Arun Ross, the textbook that they have written, especially on the data clustering, right, so they claim the same, right? So even this cannot be an endorsed best way of computing the cluster centers. Practically, it is not acceptable. It is acceptable only to the context, right? So only to the context, right? So for this context, this is what is center point, right? So but ultimately, we being the researchers, right? So we being the researchers, we should think the another very interesting word that we started in the beginning, something called the optimization, right? So that optimization has to be achieved here, right? So that we'll try to see at the later stage, right? So this is all about the kernel and the kernel function that we introduced. I'll just go quickly with this MIFCM. The reason only that we worked on this is because of the 3rd point, right? So because of the 3rd point, obviously any fuzzy value, it's as simple as the probabilistic values, right? So where even the fuzzy values falls between the 0s and 1s, right? So 0s and 1s. But I am worried about this. So this is our greedy, right? So people used to talk something about membership value, right? So people used to talk about the non-membership value, but people are not, talked too much on hesitation degree, right? So too much on hesitation degree, right? So here, membership value is basically a mutual similarity, right? So I mean, just I'm trying to map the things that whatever we discussed. Non-membership is basically the dissimilarity, right? So mutual dissimilarity. Hesitation is something where both consensus, right? So where both consensus, or sometimes depending upon the context, right? So you will simply agree, yes, I could be the center for your strategy, but that is not acceptable. Why? Right? So I cannot expect every time that Vani madam is close to me, right? So that I cannot expect, but this is only the context dependent, right? So this is only the context dependent. In some other context, right? So for Vani madam, Ashita madam will become the best neighborhood function. Maybe if they want to go to the shopping, right? So or maybe if they want to go to the some cultural activities or any other activities. Usually girls and girls goes together, right? So that is how actually the context has to be defined, right? So the context has to be defined, and in her case, in each context, the neighborhood function keeps on changes. And in some cases, right? So in most of the cases, right? So in most of the cases, due to some hesitation, right? So due to some hesitations, right? So I'll just simply pretend that I am close to one year. Even that also happens, right? So even that also happens, right? So you do many times, right? Even though if you are not happy by your not heart, your brain. There is no heart, there is only brain. Whenever you are talking machine learning, artificial intelligence, you should talk only brain, no heart. Nothing comes from heart, everything comes from brain, right? So if you have that, right, so hesitation, right, so you will try to compromise it, right? So you will try to compromise it, right? So that compromise can lead to a lot of consequences, yes or no? Because we are trying to play with the biometrics, right? So we are trying to play with the biometrics, right? So and there will be a lot of compromising issues, right? So that occurs, right? So, and that is taken care by this hesitation degree, right? So, friends, I tell you, this is another very interesting method which is not explored to the best extent. We should really give a credit. It was the year 2018-2019. Atnaso is basically a Brazilian researcher who explored this concept of hesitation degree, how forcibly the cluster centers are decided. That is called as an hesitation degree. So that is what actually the intuitionistic fuzzy set. So that is called as an intuitionistic fuzzy set. Whereas where we are going to consider the 3 degrees, membership value degree, non-membership value degree, and the hesitation degree. So all these 3 degrees put together will become an intuitionistic fuzzy. Right, so, but you need to have something like complement generator, right? So what is basically a complement generator? Right, so you need to estimate to the what level that you are trying to compromise, yes or no? Right, so you need to tell to the what level that you are compromising. Right, so for that you need to have some kind of a statistics, because we being an human beings, we are happy with only the quantitative values. We are not happy with the qualitative values. Right, so sometimes it happens, right, so in many times it happens. Right, so you know how well I am looking, how fair I am looking, can you express qualitatively? Even if you are looking amazingly today, but he or she'll compromise, no. I mean, he or she'll get convinced, no. Right, so provided if you say 10 ge 8 kana, 10 ge 9 kana, oh, this is where I stand. Right, so quantification is expected, right? So here these metrics, statistics metrics, Sujanus and Agus, there are so many metrics that are available, right? So these are the most widely metrics that are available, Sujanus and Agus method. Try to use them and formulate it, right? So and formulate it, right? So then you will get the hesitation degree, and the hesitation degree is expressed by this value, right? So don't worry about this mathematics, nothing is there in this mathematics. After all, if you want to try to implement this mathematics, it doesn't take more than 3 for loops, I tell you. Right, so it doesn't take more than 3 for loops. Right, so and it doesn't take 1 input function and 1 output function. And only core part that you should really give a thought, especially during the implementation aspect, is the strategy. Right, so what to increase, what to reduce, what to balance, how to increase, when to reduce, these are all the strategies that you need to think of. That is where actually the research goes. Right, so that is where the parameters that we have estimated. And representation, so we have this representation that is given, and the clustering method consists of 2 types. One is representation and clustering. Representation, obviously, we cannot think of many times the simple conventional matrix representation, right? So nowadays researchers are claiming that, I think you might have seen, whenever the MATLAB was in trend, people used to convert each and every data into a matrix form and run the matrix. Yes or no? Right, so but nowadays are not really like that. Right, so nowadays are not really like that. Nowadays it's something which is beyond. Right, so something which is beyond. Right, so people are thinking about the different forms of representation. You can think of your own representations. And clustering method, yes, I already discussed. So even in this case, you can make use of the simplest objective function. So here, also the distance function is here. Here this is a strategic function, neighborhood function that we have considered. Okay, so you need to update the membership value. See here, this is another advantage, another changes that we did. Previously we used a simple Euclidean distance, but unfortunately it was acting very abnormal. Right, so the entire model was acting abnormal. Then is there any theoretical foundation or any theoretical proof that you have given, that why there is an abnormality? Yes, because the Euclidean distance measure has got a fundamental property that the fundamental problem or the flaw of the Euclidean distance is to capture the neighborhood information to the best. Point number 1. Point number 2, if there is an existence of a noise, then it's gone case. You cannot really recommend the Euclidean distance. Then, right, so you need to use something else. right? So you need to use something else, and that something else is basically an Ostrov, right? So and then something else is basically an Ostrov functions. Okay, so this is basically an optimization methods that we used, because I was talking in the very beginning, because people are talking about the cluster centers more of optimization, right? So Sclera segmentation using ACO, that is ant colony optimization. I won't discuss much here, right? So because of the time constraint, right? So ant colony basically it has got its own philosophy. It is one of the biological evolutionary method, right? So biological evolutionary method that it is simply designed that how the ants are going to construct their own colony, right? So the same concept here it has been used. See here there are so many different ways, right? So to initialize the center of the cluster. So one is randomly picking the center values, k-means plus genetic algorithm, ACO, right? So more or less you can just try to explore, but we thought of exploring the ACO because of the reason that our model should be as much as optimized to the best.
Sir,
Yes, please.
regarding clustering method,
Ma'am.
what would be the maximum number of clusters that we should consider?
Yes.
Say for example, k-means clustering.
Okay.
And go for 4, 10, 12.
One of the, for example, if you take the one k-means clustering algorithms, one of the fundamental thing that we are supposed to consider is basically it is an unsupervised learning method. So, the best method, in the best method, so for example, if I consider all, right, so all the participants here as the samples, right, so as the samples in the space, right, so in this space, the best cluster that can be created for this sample is 1. Because you all comes together in a single row. Because you all comes together, why you all are sitting here? Because you are attending an FDP, right? So you are attending an FDP. So this is the best cluster, right? So only one cluster. What is the worst cluster that you can think of?
Individually.
This is one cluster, this is one cluster, this is one cluster, this is one cluster, that is one cluster. Each and every
Number of
sample
clusters is equal to samples.
That is the worst cluster. What is the average cluster? Average cluster, I mean, you need to balance. You take our Shilpa ma'am. She is sitting so sincerely, I feel really very happy. And I don't know whether I am convincing anything. I am torturing her from past 2 hours. Right, so, but I should really appreciate, right, so even though it is not a cup of tea, but still she is able to sit for 2 hours. But does she get certificate out of this FDP? Does she write any exams out of this FDP? Does she teach any, for the students by attending this FDP? No. Similarly, Manjunath. Right, so similarly, Manjunath. But still, these two are sitting here. Right, so still these two are sitting without any, without any expectation. Because that is the constraint based. Right, so that is the constraint based. Somebody has advised you, no, you are supposed to sit here, Shilpa, for 2 hours. Manjunath, you are supposed to sit here for 2 hours. Somebody has advised you because you are sitting here because of the constraint, right? So that's the average case that you can consider. Best case,
So it's
one
always
cluster.
trial and error.
Yes. Yes, we don't have a solution for that. The best cluster is one cluster. The worst cluster is each and every sample will become a cluster. The average cluster so that is why single link, complete link, average link, Watts method, these are all the different methods that they estimated depending upon the distance, right? So they depending upon the distance. Right, so I'll just simply skip all these things. These are all the results that tabulated. Some new approaches, I won't discuss anything about this. You can just go to our website. You'll get all the papers on this. But I wanted to really touch upon something which is very interesting. We did very recently. Right, so this is what the work that we did very recently. I think it is going to it's already available in the IEEE Explore. So which got published in the IEEE Transaction on Information Forensic and Security, right? So in the edition 2023, right? So 2023, and we along with myself and my student, we collaborated with many other researchers. Researchers are from Abhijit Das is from Australia, right? So Blumenstein is from Australia. and I think Upal is from ISI Calcutta, right? So Upal is from ISI Calcutta, and Pratikakis is from Turkey, right? So Gaurav Gupta is from US, right? So similarly, we worked from the multiple teams, and we approached or we proposed this method. I mean, it's not basically a proposed method, I would rather say. So we consolidated all the research works that are done from 2017 to till date, right? So to till date, by considering irrespective of the data sets that are available, any number of data sets, right? So different types of models, different types of metrics. Can I take another 10 minutes, madam?
Yes, sir.
Okay. So that is what actually we put up in this paper, right? So we put up in this paper, and anyone who is really wanted to start their research work, especially on this Sclera, I don't advise this is a best paper to start with, but I advise if you read this paper, you get so many different references, right? So you get so many different references that reference could be a best breakthrough to really work for your 5 years, PhD work, right? So 5 years PhD work. So he is from Greece, Vitomir, right? So he is from Greece. So this is what the work that we did. See, bias and fairness of biometric algorithms are the key topics, right? So nowadays, we don't give much, we don't give much priority for this biasing, right? So biasing, once again, it depends upon the various context, that how you are going to define yourself, right? So that how you are going to define yourselves. And this is a biasing word which we exploited, or which we explored, especially from the field of psychology, right? So especially from the field of psychology, right? So because that is how actually psychology is basically the study of human brain, right? So in many contexts, right? So people will think, right? So people will think in different ways depending on the context, right? So depending upon the context, right? So but if you try to match this, if you try to map this, the fairness of any biometric algorithms, right? So should be unbiased, right? So should be unbiased, right? So I am not really there, right? So to accept and any kind of even 0.1% of biasing that exists in my data that I am going to capture. So that was the actual fundamental objective of this paper, to investigate bias and fairness of Sclera segmentation model, right? So Sclera segmentation model, right? So 4 fundamental questions we put ourselves, right? So we just took all the opinions and we coined the 4 fundamental questions, right? So the first one is, how well do contemporary models perform in the task of Sclera segmentation model with diverse input images, right? So the catch is diverse input images, right? So irrespective of the context that we go for the image acquisition, right? So how well, right? So my contemporary models will work out. Question number 2, which subject or data characteristics represent the most critical source of bias for Sclera segmentation model, right? So you should really come out with, right? So you should really come out with something which is very unique. So if you show this, definitely it will be biased, right? So if you show this, definitely it will be biased, right? So which is that characteristics, right? So which is that subject, right? So which is really giving lot of rooms, right? So which is giving lot of rooms towards the consideration of more biasness during the building of Sclera segmentation model. Question number 3, right? So what impact do training data characteristics have on the bias exhibited by the segmentation models, right? So while training, what could be the impact of the biasness, right? So that it has to be considered. Can we mitigate the bias exhibited by the segmentation models without losing segmentation accuracy, right? So these are the 4 fundamental questions that we arised ourselves, right? So and these 4 fundamental questions are arised by giving a lot of discussions among ourselves, among our network, and also by reading all the contemporary biometric research, not only with respect to this Sclera, by considering all the fundamental biometric research articles, and we arrived at. But these 4 fundamental questions are not related only to this Sclera. Maybe it can also be extended. You can put these questions, right? So you can put these questions on your own, and you can really see, right? So how best it can be mitigated, right? So maybe these are some of the best data sets that are available, and we implemented all the approaches in almost all the data sets that are available, right? So I don't really discuss in depth, right? So I don't really discuss in depth. Probably, I'll just give you the DOI, or I'll just give you the details of the paper that is available. It is freely available. Otherwise, you can just go to my website, right? So you can freely available that paper, and you can go through this. So this is the first data set, right? So which exists for the Sclera, that is MASD, multi-angle Sclera data set. Second one is SMD, that is Sclera mobile data set. So where we are going to capture the data through the mobile devices. Sclera liveliness, right? So liveness, I was telling, right? So in the beginning, right? So Sclera liveness, you need to see whether the Sclera, maybe once the person is dead, probably it will take, certain minutes, right? So to get, these cells to be dead, right? So before that, can you capture something, right? So liveness data set. And then we have Sclera blood vessels, pericular and iris. So it is called as an SBVP data set, right? So each data set has got its own, it has got its own number of. But if you see here, the interesting thing that that I wanted to really present here is, see, we started with 2,624 RGB, and then we went to 500 RGB images of 50 eyes, right? So, but with the mobile data set. But if you see, it goes on increasing. See here, so it gives 1858 images out of 110 eyes, but there are 55 subjects, right? So, and the specification of the camera also changes. It is captured in the DSLR camera, right? So where higher resolutions will be captured, and simple to design and develop any kind of an algorithms. So this is the mobile ocular biometrics in unconstrained settings, right? So unconstrained settings. Right, so these are some of the 5 data set that I wanted to mention. MASD, which is most widely used. So in the second one is SMD, the third one is SLD, the fourth one is SBVPI, right? So and the fifth one is MO Mobius, right? So these are the 5 data sets that are widely that can be used in order to explore the data set. And the simplest statistics that we considered, especially to evaluate the biases, one is the standard deviation, so which is very well known to you. We studied from class 7, right? So standard deviation, and the next one is mean absolute deviation, MAD, right? So these are the 2 metrics that are used to evaluate the bias, and these are the different models that are available and evaluated. We evaluated Sclera segment, right? So Sclera UNet2, MUNet, FCL8, CGNS, and RGB SSIMS, and Sclera Mark RC NN. Right, so these are the different models that we evaluated. But maybe a question arises, that is quite a very obvious question that is expected by any participant: why not deep learning? So I strongly don't recommend deep learning. Right, so I strongly don't recommend deep learning, because deep learning has, I'll not say it's imitation, deep learning has got its own pluses and minuses. So it is a fancy word, right? So deep learning is a fancy word, right? So it is like somebody is sitting and doing everything inside, and you don't know what exactly you got, how exactly you got, right? So that is I don't say it's basically a problem, but you try to build that learning, deep learning. So then you will be highly appreciated. So these are some of the model descriptors that we implemented. And in order to check the biasing, so one is eye color bias, right? So eye color bias, right? So probably the same set of eye, if I see tomorrow, maybe they'll be with a different eye color. Probably they may wearing the lens or something else. And ethnicity, yes, this is very interesting, ethnicity, because depending upon the geographical location, the the color of the eye also varies. If you see Serbia, especially Russians and Serbians, they'll be having a dark blue shade of eyes. And if you just go to the Western, they'll have an something the very different types of the appearance. But if you see our own eyes, right, so it's more of blackish, right? So blackish kind of an appearance. So ethnicity, acquisition hardware, right? So the type of hardware that you are going to use, the gaze direction, right? So gaze is basically how right? So continuously you can monitor it, right? So the gaze, right? So it's not only the straight view, it could be left view, right view, up view, or down view, right? So or any kind of view, right? So the direction and representation bias, right? So representation bias basically deals with how mathematically you are going to deal with the Sclera representations. Okay, so this is in conclusion, right? So these are all some of the things that we discussed. We started with histogram and clay, then we explored something called fuzzy seamins, and then we explored, I mean, this point we have untouched because I didn't discuss anything about the symbolic fuzzy seamins. So Professor Guru sir was also telling, and some of the research scholars has exploited the fuzzy symbolic representation. The same thing can also be, beauty of the symbolic is it tries to capture the real-time data, right? So real-time data, and you can give the different forms of representation like crisp, multi-valued, interval valued, etc. Right? So and then the other pre-processing techniques, we explored the spatial information through the introduction of kernel spatial information, right? So and also we use symbolic, but we didn't present it, and we used the ant colony optimization as an optimization algorithm. So I thank my research students, Dr. Arun, Dr. Maheshan, and Dr. Rupa, so who prepared these slides and made me to easier, right? So for the presentation. And if you want to find really any interesting our publications, right? So all publications are made available, right? So in my ResearchGate profile, it's an open access. You can just go to Google and type my name, and you will get all my publications that can be downloaded. Okay, so this is what actually I wanted to say. Questions are guaranteed in life, but answers I'm not really sure. I don't know whether even if I give the answer, I don't know to the what extent that you are going to get convinced, right? So hence answers are not. Any questions? I am open to take.
Sir, is there any actual comparison between the iris to Sclera?
Yes, there are many works that are attempted. In fact, the initial works are started with the comparison with the iris and the Sclera. But in most of the cases, this Sclera has outratedly given the best results when compared to the iris.
Actually, I wanted to know about the application wise, like because major of the applications like continuous monitoring and all, they have been using the iris. So is there any chances of Sclera replacing those systems?
Yes, madam, definitely yes. Because as I said in the very beginning, because of its simplicity, because iris really requires NRI, illumination, acquisition, device, right? So that can be simply replaced for the Sclera, because even for Sclera, even a simple mobile devices, because I started in the very beginning saying that why the so many number of smartphones, what these smartphones are going to do with this. These smartphones are going to do with this kind of an acquisition of the device, even with the 1 megapixel of camera, right? So even with 1 megapixel of mobile camera to the 48 megapixel of the mobile camera, right? So but the same acquisition doesn't work with the iris, because acquisition with the iris, right? So acquisition with the iris really needs the NRI, NRI. Right, NRI cameras, right? So NRI cameras. So most probably yes, the day progresses. Definitely, people will be more interested in using Sclera rather than the iris. But it's a debatable. Any biometric is debatable because it has got its own challenges like biasing and all, as I said.
Sir, sir, in continuation with that, like you also mentioned about the unconstrained data set of the Sclera. Can you just say like what sort of things? Because I had a thought of like Sclera acquisition. It might be in a proper constraint, like you should require in a constrained environment to capture the data. Likewise, like it may get influenced by the weather, environment and all. Like if we travel for a distance and our eyes may get influenced with the redness and all. So I felt like actual data set requires an exact constraint scenario for any certainty of the
Yes,
Sclera.
yes, you are right. So the reason is constraint and unconstrained. Why this constraint and unconstrained plays a very important role. Constraint is always the very well sophisticated set of environment that you create and you capture the image. But practically it should not be like
Yes,
this.
and for real time.
Right. So for the real time application, this constrained environment is not really acceptable. Whereas madam said something, you travel, right, so your eyes will become red. But the beauty of this Sclera is the redness appears only in the iris but not in the patterns. Right, so the projections of the redness, as soon as, I mean, even if you just rub your eyes, right, so after 2 minutes or 3 minutes your eyes will become red, and that part is your iris but not the actual Sclera. The Sclera patterns remain same. The only the some kind of an the reddish occurs only in the iris part. So yes, in most of the cases, even if that is the case that is appeared, right, so the Sclera is really acceptable when compared to the iris, especially for the unconstrained environment. Sclera is highly recommended in the iris, because a simple mobile phone that does your job, that is more than enough.
And if it's a color dependent that kind of thing, right, redishness, that can be filtered out.
Yeah, definitely. Yes, a simple enhancement technique or 3% techniques if you use, right? So because ultimately you are bothered about the patterns, not anything else. You are not really worried about what could be the color that appears.
So out of my curiosity, I should not have put the symbolic representation. But you use that for representation purpose or for completely the process purpose?
So out of curiosity, I mean, just to answer this question, the symbolic models is one type of models which really needs some kind of an unconventional representation. Right. So if you don't give the unconventional representation, I mean to say, right. So don't try to capture or try to place the data conventionally. Means I mean to say, just try to keep something which is in the matrix form. Right, so where the matrix keeps the pixel value. These are all some of the very unconventional way of keeping the things. But can you capture the variations that takes place? For example, the minimum value and the maximum value. Right, so that basically requires the representations. Right, so once always the any symbolic based works that we are going to do should always start with the representation. Otherwise, you cannot really say that it will become an symbolic is basically for the representation. Yes, in this case also, we have started with representation and then we have used symbolic clustering for this. I think first 2 chapters of Dr. Bapu P. Kirangi thesis will tell you why the representation is important for the symbolic data.
Is the Sclera data is a persistent, like does it change according to the age or the person?
No. Even from day 1 to the last day, right? So till it dies, right? So it remains same. And even the twins, right? So will have a different setup and Sclera. And even the left Sclera pattern is different from the right Sclera pattern. So that is the plus point. Okay. Any other questions? Okay, so if you have any other questions, maybe you can drop me an mail, bsarish at jsstiv.in if you need. Otherwise, you can just go to Google, and if you want to see our research articles, you can download the research article and you can read. So I thank personally the organizers, Professor Bharti ma'am and Professor Ashita ma'am, for giving me this opportunity to share some of the this is not basically my research, right? So this is not basically my research, but this is my students' research, Right, so and all the credit goes to my team, those three that I have mentioned. And they are the one who designed, developed, tested, and documented and published. I don't know why they gave my name. Right, so
Because
but
you are the super, see,
right,
that is
so
the humbleness that
but
you are showing.
but the credit goes to them. And also I thank each and everyone for your patience listening. I don't know whether to the what extent I penetrated your needs. And especially I thank Shilpa ma'am and Mr. Manjunath for the solid 2.5 hours sessions that you sat, right? So irrespective of the understandability or the level of discussions that we are making. So I wholeheartedly thank everyone. You need not to thank me, madam. So it's our duty.
No, sir. We wholeheartedly thank you for this wonderful session, because this is the last technical session of this FDP, and you did really a very good job in concising all the aspects, starting from the title, covering all the traits, taking Sclera as an explicit trait, and delivered the talk. So we wholeheartedly thank
Thank you.
from our organizing committee. This is just-
Good. This is a good time.
ಫೋಟೋ ತೆಗಿಯಲ್ಲ ಅಂತ
Thank you.
So now we shall break for a quick lunch and move